Hello, in this video we're going to have a look at the Mellow Fly-E3-Pro-V3 and get it set up with RepRapFirmware. So the first question is, I suppose, what is the Fly-E3-Pro-V3? Well, it's a board that's the same size as the Ender 3 control board, so it's a drop-in replacement for the Ender 3, the Ender 5, but could be used on any 3D printer that requires 5 drivers or less. On board it's got 5 TMC2209 drivers. On the back it's got an ESP32 for fast web interface, and it's got an STM32F407 MCU that runs at 168 MHz with 1 megabit of flash. So I'll start by going to the TeamGloomy Wiki. This is where you'll find all the information about all the boards supported by the TeamGloomy port of RepRapFirmware. So just a few things to run through with the Fly-E3-Pro-V3. If you're not using the second Z driver output, then you need to add jumpers as shown in the image here. And one of the things about the Fly-E3-Pro-V3 is that it's got 3 power inputs rather than 2. So this basically enables you to control the drive, heater and fan power supply to the board with an extra relay if you choose. So this means that when the printer is on, power is being supplied to the MCU and the ESP to provide the web interface, and then you've then got control over the relay to turn it on and off as and when required. But in this instance we're not going to be using that functionality. You need to make sure that you add power, positive power to 1 and 2 and ground to 3, otherwise the board won't work properly. Another thing with these Fly boards is they have changeable fan MOSFETs. So if you do burn out your fan, you can just remove this small little MOSFET from the board and replace it with a new one. Now when you come to install these, they can be installed either way around, so it doesn't matter. So I've got my board here ready. It's not been flashed with anything. You can see that I've attached the Wi-Fi antenna, the fuse, the power, the fan MOSFETs, and I've also put the jumpers on the Z headers. So on the TeamGloomy Wiki there is a page called Connecting via Wi-Fi specifically for the Fly-E3-Pro-V3, and it walks you through what you need to do, but I'm going to go through this now in the video. And one of the things that TeamGloomy provide is something called the configurator. So that's here. So this allows you to generate a config for your printer and for the board that you're using. So I'm going to follow this through as if we're setting up an Ender 3, but the same applies to any board. So I'm going to select here Ender 3. If you're not using an Ender 3 or a VZ bot, then you can just click Custom Configuration. So this list here gives you a list of all the boards that are currently supported by the STM32 port and LPC boards as well. So we're looking for the Fly-E3-Pro-V3. So here you can set the printer name. This is displayed in the web interface and is also used for the MDNS. So you could go to ender3.local. That's an easier way to get to your printer. I suggest ticking this box here, which is the read config override file at the end of the startup process, because you'll need that in place when you start PID tuning your bed and your heater. An Ender 3 is a Cartesian type printer, but you can also use this to configure Core XY, Core XZ and Delta. And then the home preferences, you don't really need to change any of those, but if you are setting up a Delta, I do suggest ticking this box here to set a higher dive height for when you first calibrate the printer. So on the I/O mapping page, unfortunately one of the limitations of the config tool as it currently stands is that you can't assign more than one driver to an axis. So if you've modified your printer to have 2 Z motors or anything like that, then you'd have to configure that afterwards. You wouldn't be able to do it as part of the config tool. So here we've got 4 axes set up, X, Y, Z and the first extruder, and we've got end stop pins set. If you look at each one, there's 4 options. So X stop, this would be basically for normally closed setup switches. This one, active lows for normally open. And then you've got both those options again, but with a pull-up enabled. This board you can have up to 4 controllable fans, but for a standard end of 3 you'd only want 2. Well, you might want to set the electronics fan, but I'm not going to set that in this one. So you've got fan 0 and fan 1. Then your heater outputs, you've got your bed with your output and your sensor, nozzle, same. If you did have a Z probe, for example something like the Corality Touch, you would select probe for the input pin and servo for the output pin. Make sure you select those if you want to be able to select a Z probe later on, but in this guide I'm not setting one up. The motors page then allows you to tweak how the motors work, so you can change the direction. You can set the micro stepping with interpolation, whether it's on or off. The recommended setting for RRF is 16 with on. You can set your steps per millimetre. There is a nice little calculator here to help you calculate the steps if you don't know. Then you've got the max speed, which is your jerk, then the maximum allowed speed, and your acceleration, and then your motor current. And just remember that if you're coming from Marlin or Clipper, they use RMS for the motor current, whereas RepRapFirmware uses peak. So to change from RMS to peak, then you multiply the values by 1.4. And then motor current reduction. This is basically that, for example, if you home your machine and leave it 30 seconds, then RRF will drop the current from this to 30%. You can modify these values, but I would suggest leaving them as they are. End stops. So basic switches. You can configure sensorless as well. Let's just turn on the Z switch. And then the end stop location is where they are on the axes. So on an end of 3, they're on the low end. On something like a Voron V0.1, they're on the high end. And then for the Z probe, if you were setting one here, you can set the X and Y offsets if you're aware of them, otherwise you'll need to measure them. Whether you need to use deploy retract, and the type of probe. So depending on what type of probe it is, it depends on how it's treated within the firmware. You could also set the Z offset as well. So this screen, this page here is for setting the PID tuning settings. So I recommend PID for the heated bed. 4092 is the standard thermistor settings for an end of 3. But for example, let's say you've got a V6 fitted and you want this one here, and that'll set the right information. But if you do have one that you don't have, that's not in the list, but you have the temp table for, you can go through and configure and it will work out the correct values for you. Onto the fans. So fan 0 should be the part cooling fan, and fan 1 should be the hot end fan. As you can see here, part cooling fan is not thermostatic control, so it's not monitoring any heaters, whereas the hot end fan is thermostatic control and monitors heater 1, which is the one in the hot end. So this fan will come on when the hot end goes above 45 degrees. For the tool preferences, I recommend unticking this box. Especially if you've only got one tool. If you've got more than one tool, then you may want to keep that in, but really you'll need to modify your tool change files anyway. And if you've got one tool, I definitely recommend ticking this box, which will load tool 0 on when your printer first boots up. And the rest of these options here are for if you've got more than one tool. So you can set the tool number, give it a name, set the extruder driver to use with it, which heaters, which fans, at any X, Y and Z offsets. For compensation, as we're not using a probe, we're not too worried about this screen, but you need to take into consideration things such as the probe offset. So for example, if your probe is 30mm to the right of your nozzle, so that's in X30, to be able to probe at X15 your nozzle will have to be at -15. So 15 minus 30 is -15, and that'll be outside your axis maxima and minima. So you need to make sure that when you set these locations that it's possible for your probe to get there. For network settings, this is the password that you can set on the web interface, but it's not very secure because it's sent in plain text, so I wouldn't really rely on that as a reliable method of keeping your printer secure. If you know that the Wi-Fi module on the board has firmware already on it, then you can fill these in with your Wi-Fi SSID and the password, otherwise I wouldn't bother. And the rest of these are all filled in automatically, so unless you know that you don't have anything standard, then don't worry about changing those pin settings. And finally, just make sure all those boxes are ticked and press the finish button. So then this will bring up this configuration ready, and these are just links for you to download the latest stable versions. And then if you click on the download configuration bundle as a zip, you can download those all together. So I've already done that. So I have them here: Direct Web Control, the Wi-Fi firmware, and so I already have all the files downloaded here. So there's the config collection, the Direct Web Control files, the firmware for the ESP, and the firmware for the STM32. So now we need to create everything on the SD card. So if we go to the E drive, we're going to need some folders. First one is firmware. The next one is macros, sys, G-codes, and the www folder. So you need to make sure that your SD card is formatted as FAT32 and is no larger than 32 gigabytes, and I would say really no smaller than 8 gigabytes. So we're just transferring the files over, so we're just going to unzip both of these. So the Direct Wi-Fi server needs to be renamed to get rid of the remainder, and just called that, and that goes in the firmware folder. The firmware by itself just needs to be renamed to firmware.bin. And then in the config, we move everything out of the sys folder and put it in sys. And then everything out of the Direct Web Control folder we move to the www folder. And the rest of these can now be deleted because we don't need them. So if any of you used RepRapFirmware before, in the sys folder you'll notice there's an extra file called Board.txt. And what this does is it tells the firmware what board it's running on. So it has the board name, the correct pins for the ESP to communicate with it, how many smart drivers it's got, and there's extra things that you can add, and they're all detailed within the wiki. So on general, so STM32 board.txt configurables, it tells you everything that can be changed within that board.txt file, and it gives you an example and a description about how it works. So that's everything we need. So I'm going to take the SD card out the PC and plug it into the Fly board. Let's get that turned on. I'm just going to plug in USB-C. So you'll hear it ping. And we'll just have a look at the device manager. So there we go. And that's it there, COM port 14. So we recommend using putty to communicate with the board. So as you can see, the firmware is flashed. So now we're just going to go through the process of flashing the ESP. So send M552S0 and then M997S1, and basically all that's doing is taking the firmware file from the folder called firmware and flashing it to the ESP. So there you can see that the firmware is now flashed. So we're going to send M552. So there you can see the firmware is flashed and it's got to the end. So we're going to send M552S0, and then we're going to send the Wi-Fi details. So M587 obviously those aren't my Wi-Fi settings, so what we're going to just do is I'm just going to send those now. So I've sent those, so I'm going to send M552S1, and what that's doing now is that you can't see, but it's flashing a blue LED on the board just to show that it's checking for a Wi-Fi connection, and there we are. So if I browse to and here you can see this is the web interface that you get with RepRapFirmware. So it's an event notification because it can't read the hot end thermistor, which is fine because I've not got one plugged in. But just to give you a walkthrough, so you can see the name that we gave the printer earlier, Ender 3. So this is the status box. It shows you what the position of the print head is in, how much plastic's extruded, the speed it's requested it to travel at and what it's actually travelling at, and the sensors. So you can see here that I'm running this with a 12 volt power supply. Something to note is that the Fly boards are the only ones that have voltage monitoring on them, the rest of the boards don't. This is the temperature of the MCU. Here you can control the temperatures of the hot end and the bed, and here you'll see a temp chart. Then down here, this is where you would home the machine. You can run true bed leveling if you've got that capability, and mesh compensation to get the height map. This is your extrusion control, so you can manually extrude and retract, and this controls your fan. Now, some people don't understand, they think that the tool fan is the heatsink fan and the part cooling fan is the part cooling fan, but they're actually both the same thing, especially in a single tool environment. And what this is the part cooling fan of the currently selected tool. So if you have 5 tools, say tool 3 was the one that was active, that tool fan will be controlling the fan that's on tool 3, and then you can still individually control the fans as well by selecting the appropriate tag. The console allows you to send commands and get information back. So you can see that M122 sends you information about the firmware. This shows you that the 4 drivers are being identified. It shows you information about the Wi-Fi. And another useful one to know is M122P200, and that shows you what pins are assigned to what items in Board.txt. So it's a good way of verifying that what you set in Board.txt is actually being recognised. It also shows you all the names that are available, whether anything's on any of the hardware timers, and whether anything's got any interrupt pins. So this is where the height map would display if I had a height map, but I don't. But that was shown there. The status screen is shown when you started to print. So it gives you control over things like the speed factor, the extrusion factor, and shows you information about how long it estimates the print time to be. Filaments I won't go into today. Jobs, this is where your G codes get uploaded to and where you start your prints from. This is where you can have macros set up, and the system is showing you the contents of the sys folder. So here you can go into those files like Board.txt, edit them and resubmit the changes, and the same with config. So there should be no need to remove the SD card going forwards. If you're updating the system, you can upload things using the upload system files button, and that will allow you to upload Wi-Fi firmware, normal firmware, updated dual web control. If you have a panel view, you can update the panel view over the web interface. And then the general shows you what version of dual web control you're running, and lets you change some settings like use a dark theme rather than a light theme. You can also force the dashboard mode, because there is a CNC version which makes the numbers a lot more prominent so you can read them easier. There's machine specifics, that tells you about what firmware versions you're running, allows you to install updates and some other bits and pieces. You can preset some of the temperatures you see in the drop down boxes. And then plugins is where you can start and stop extra plugins like the G-code viewer, the object model browser, and you can install plugins. So the object model browser is another good one. I'll just run over that now. So basically this tells you all the information about your printer. So you can see that you've got one board here, and it fills all of this in, so it's worth having a look through, and then you can reference all these items within your G-code if required. And that's it. So now you're fully up and running, I would suggest that you look at doing something like PID tuning your tool or your bed. There's information about that at the end of the corresponding Wi-Fi page down here. And there's also information about connecting other things like, well, doing things like sensors homing, connecting a serial screen such as a Big Tree Tech TFT or a panel view, using a 12864 screen, BL Turch accelerometer, and another useful one is pin names, so that it shows you all the layout of the board, and then gives you lists what pin and what its name is in the firmware. So thank you. Hopefully that's been a useful video. Again, you can apply this to pretty much any board that TeamGloomy support. The process is pretty much the same, but feel free to reach out on Discord if you need any help. Thanks very much.